Question 1. 2 ordinary fair dice, one red and the other blue, are thrown. Event A is the score on the red die that is divisible by 3. So the score on the red die that is divisible by 3, we are looking at a score of 3 and 6. These are on the red die that is divisible by 3. And event B is the sum of the two scores that is at least 9. So the sum of two scores that is at least 9, we have greater than or equals to 9. So we have 9, 10, 11, 12 as the sum of the two scores. So part A, find the probability of A intersect B. It is easier if you just write out the outcomes for the red die and the blue die. So you just have 1 to 6 and 1 to 6. And then what you have here is the sum of the two scores. So you have the outcome of 1 and 1 that will give you a sum of 2. And the outcome of a 6 and a 6 gives you a sum of 12. A is the event where the score on the red die is divisible by 3. So the score on the red die that is divisible by 3, that would be 3 and 6. So this is red die divisible by 3. So we are looking at all these outcomes here. 3 and then 6 here, where the score of the red die is divisible by 3. And we look at B, where the sum of the two scores is at least 9. So the sum of the two scores is at least 9. We are looking at all these outcomes. The blue highlighted one would be the outcome of event B, and the yellow highlighted is the outcome of event A. The probability of A intersect B. So let's look at this. In total, we have 36 outcomes. And the outcome of A intersect B, we have 1, 2, 3, 4, and 5. So A intersect B results in 5 outcomes. Then the probability of A intersect B is 5 out of 36. Part B, hence determine whether or not the events A and B are independent. If A and B are independent events, then probability A intersect B, that is probability A times probability B. So let's look at probability of A. Probability A, there are 12 outcomes for event A. So that is 12 out of 36. That would be 1 out of 3. And probability that B occurs. So let's look at the outcome of B. You have 4, 3, 2, 1. So 4, 3, 2, 1 will give you 10 outcomes. B has 10 outcomes. That is 10 out of 36. So you have 5 out of 18. Now we find the product of the probability of A and the probability of B. We have 1 over 3 times 5 out of 18. That will give us 5 out of 54. And clearly, this is not 5 out of 36, which is the probability of A intersect B. We see that the probability of A intersect B is not the product of the probability of A and the probability of B. Then we say that A and B are not independent. Question 2, the probability that a student at a large music college plays in the band is 0.6. Let's say B is the event of playing in the band. So the probability that a student play in the band, that is given by 0.6. For a student who plays in the band, the probability that she also sings is 0.3. This is a conditional probability. Let's say that the B, S is the event of singing. Then we know that the probability that she sings, given that she is in the band. So we started with this for a student who plays in the band. The student is already in the band. The probability that she sings is 0.3. So we have probability S given B equals 0.3. For a student who does not play in the band, so the student is not in the band, so it's a B complement, the probability that she sings is X. The probability that a randomly chosen student who does not sing, that is 0.58. From all this given information, we need to find the value of X. For conditional probability question, it is much simpler to just solve it by drawing a tree diagram. We started with whether a student is in the band or not. Then we have these two cases here. We have a student that is in the band and a student that is not in the band. The probability that the student is in the band is 0.6. Then the probability that the student is not in the band is 0.4. Whether the student is in the band or not, she or he could sing. So probability of singing and not singing, singing and not singing. Probability that she's in the band and sings is 0.3. That gives us 0.3. Then from total probability, we know that this is 0.7. A student that is not in the band but sings has a probability of 0.4. This is X. Therefore, this would be 1 minus X. Now we use the fact that the probability that the student doesn't sing, this is 0.58. For a student who doesn't sing, we look at this and that. That will give you the probability of student who doesn't sing but is in the band, and this would be the probability of student who doesn't sing and is not in the band. So probability S complement, that would be 0.6 times 0.7 plus 0.4 times 1 minus X. That is 0.58. 0.6 and 0.7, that gives us 0.42 plus 0.4 times 1 minus X. That is 0.58. We can rearrange so that 0.4 times 1 minus X is 0.58 minus 0.42, and that is 0.16. Divide throughout by 0.4 to isolate 1 minus X. This will end up 1. We have 1 minus X equals 0.4. So X must be 1 minus 0.4, which is 0.6. Part B, 2 students are chosen at random. Find the probability that both students play in the band and both sing in the the students, whether they play in the band or sing, that is independent. So find the probability of one student that is in the band and sing. Band and sing would be 0.6 times 0.3. And that is 0.18. But because we have two students here, so probability that both students play in the band and both sing, that would be probability of one student. That is the probability of a student who play in the band and sing. You multiply this by the probability of the second student who is in the band and sing as well. So that is 0.18 times 0.18, and we have 0.0324.